Welcome to TJ Cross Engineers Incorporated Quality Assurance Module 2 training. Today we will be discussing the collaborative plot plans and P&ID. This is a supplement to the Quality Assurance Roadmap. In this training exercise, we will teach the project manager skills to facilitate team collaboration for plot plan and P&ID development during scoping and front-end engineering. The team can present the quality concepts of the design to the client and quality assurance team for early input. We will then have a role-playing exercise to help you apply your new skills. We will start by reviewing the quality roadmap. The two critical areas during FEED are the development of the plot plan and the P&ID. We will use collaboration during working meetings and successively develop the designs. The team will focus on certain critical areas and obtain quality assurance and/or lead and client input. At the conclusion of this work, we will issue the plot plan, 30% civil, 90% P&ID, and 30% electrical packages. During plot plan development, the project manager will facilitate input from the civil, structural, mechanical, and electrical engineers. We will need the following: the process flow diagram, equipment sizes, quality success factors, well locations, existing 12 kV, the process design basis, client spacing guidelines, and the plot plan checklist. In the past, we developed plot plans using the paper doll exercise. The team would use a topo map, a scale, and equipment drawings to get started. We would cut out the equipment dolls and then arrange them on the topo map. However, it was difficult to discuss elevations, drainage, and grading and provide much detail. Now we have a 3D software tool to help us collaborate. First, we will collaborate on locating the facility. We will consider a clear location that is central to wells, not under major power lines, accessible from the roads, close to tie-ins, and will not receive runoff from other areas. After that, we will field verify the locations, checking for buried obstructions, and then select the best site. We can use SketchUp to collaboratively develop a plot plan. In this example, we can import equipment into Google Earth and have the team work together to lay out major equipment, roads, and corridors. We are about to view an example of a steam plant and equipment. The first thing we did for our plot plan was to import the terrain from Google Earth into SketchUp. This is helpful because we can also see the locations of existing roads, power lines, tie-ins, equipment, wellheads, etc. This will help us establish the ideal plan location. We are not limited to this chosen location. We can look at the surrounding area with the same amount of detail to locate similar desirable potential sites. Once we begin designing, we can grade relative to the terrain and clearly see potential drainage issues. This is also beneficial for routing pipelines. Once we start adding equipment, we do not have to create every piece we want to include in our model. Instead, we can import much of our equipment from existing CADWorks models and also libraries online and on our server. As demonstrated, the three-dimensional model will assist the project managers in facilitating input from the civil, structural, mechanical, and electrical engineers. During plot plan collaboration, we need to consider many issues. The civil engineer needs to think about site drainage and AB 1960 regarding containment of any spills. The electrical engineer needs to provide input on area classification spacing for equipment, panels, and instrumentation. We will also need to take into account accessibility, piping and control tray layout, sloping lines, overall site drainage, overflows, code clearance, and future equipment tie-ins. Now let's move on to P&ID collaboration. In the past, we reviewed P&IDs with teams using the page-turner technique. Few people spoke and no one really paid attention. In the new way, we can use our SketchUp model to help collaborate with our teams. In P&ID development, the project manager needs to collaborate with the process, controls, instrumentation, and mechanical engineers. The team needs to bring preliminary instrument data sheets, equipment data sheets and curves, process flow diagram and design basis, line sizing and overflow calculations, piping specifications, the process narrative, and the P&ID checklist to the working meetings. Now let's first review a few examples of some process equipment. In this first slide, we can see the internals of a free water knockout and the separation of emulsion and water. We see the production hit the internal baffles and free water falling to the bottom. Gas rises to the top. Emulsion is then floated over a solid weir. We can see control valves and devices that manage interface and overall levels. Here is an example of a wash tank and heater treater. We can see how the fire tubes or steam coils are placed to heat the emulsion to separate oil and water. This example shows the removal of oil from a surge tank using a floating skimmer. Here we see the rising bubbles in a static flotation cell and in a gas flotation cell that aid in the removal of oil from produced water. These examples demonstrate the use of color and animation to explain functionality. Now let's apply this to P&ID collaboration. In this SketchUp model, we will demonstrate the power of a three-dimensional model over the typical P&IDs and other two-dimensional drawings. Here you can see the overall view of the plot plan with different tiers in the existing power lines. The project manager has added the design rates to the inlet stream. He has also linked the data sheets to control valves so the team can review the sizing and process parameters. We can even cut away sections of the equipment and show internals. Inside this free water knockout, we can see the inlet production, the solids, the water, and the oil and gas separation. We can also use this model to discuss the level, temperature, and flow controls in the vessel. Again, we are able to link the data sheets or any other equipment information to valves and equipment, which will add value to team reviews and allows us to be more efficient when addressing client questions. We can also do this for other vessels and tanks in our models. As we have just demonstrated, the 3D model goes a long way toward explaining a design's functionality, which is important and time-saving for both the team and the client. Visualization helps everyone understand the design. It can help educate the team and solicit early input from the client and the quality assurance group. We can also use these simple models to start the development of the P&ID. During P&ID and PHAs, we can review these models beforehand with the participants so they can visualize the design. Also, we can develop these models further for operator training. During the P&ID collaboration, the team needs to consider the following: equipment functionality, line sizing, piping class and spec, sizing of control valves and PSV scenarios, instrument type and selection, process protection, safety systems, abnormal flows, startup and surges, process control narrative, and metering needs. Now we will start the role-playing exercise. We have 3 role-playing exercises for the project managers. In the first exercise, we will have a project manager facilitate input from the teams for location siting using Google Earth. In the second exercise, a project manager will collaborate a team to develop a plot plan using SketchUp. In the third exercise, the project manager will collaborate a team during P&ID development with SketchUp. The team can use these basic models to begin dialogue with the quality assurance group and client for early input. The project manager can facilitate discussions to explain the following: the reasons for the design, why the design achieves quality success criteria, and the possible alternatives and trade-offs. Once these issues are resolved, the team can begin development of the plot plan and P&IDs. Google Earth and SketchUp should be used only during feed and scoping. They will not replace obtaining survey data, field verification, or using CAD, PDMS, or CADWorks during detailed engineering. Please be aware that Google Earth has limited accuracy and may not have updated information. However, these software tools can be used to get us headed in the right direction of a quality design. This concludes Module 3 of our Quality Assurance Roadmap series. In Module 4, we will be discussing collaborative detailed design.